Okay, so today we are going to learn how to write problems as logs that didn't necessarily start out as logs. So it's actually very easy. If we have a problem with, we'll just start with something simple, x equals x, just so that I can define a rule here. If I have this, I can actually write log x equals log x, and it will not change the truth of my problem. So anytime you have monomials, okay, again, where you have addition or subtraction, that will screw things up. But if you have multiplication or addition, you can, or multiplication or division, you can just put a log on the front of each problem. So starting with our first example, if we have y equals a squared b, and I want to write that using logs, and I want to write it as simple as possible with logs. So you're going to end up with a lot of logs in your problem. The first thing I can do is I can just go ahead and throw a log in the front of both of my monomials. Now, log y is going to stay this way all the way down. When we're done, we're still going to have log y, because it is a log and a variable. There is nothing else involved. But everything else is going to change a little bit. So I start out with this log a squared b, and I want to get a single variable in each log if possible. So we're going to change it to log a squared plus log b. That uses the same rules I learned yesterday about the fact that if I have two terms multiplied by each other, it's the same thing as them added together as logs. Now the next thing I'm going to do is I'm going to get rid of the exponent that's in this problem here. So we're going to write this as 2 log a plus log b. So now my problem, I have a single variable in each log. There are no exponents. They're as simple as they can be, but it does look kind of long. But that's okay. All right. So this is my answer. I'm trying to get this, I guess you could call it expansion. I'm trying to get logs, the problem expanded out as far as possible. So there's absolutely nothing else I can do with this. This is the answer. You will not come up with a single number. You will end up with expressions and equations as your answers. So that's the first example. That was a fairly easy one. Let's try another one. We're going to go log, well, we'll start with the equation. P equals 20 over the square root of n. So we're going to do the same thing we did to the last problem. We're going to throw a log in the front of each of those terms. Log p equals log 20 over the square root of n. Now again, log p is not going to change, but this right here, this 20 over square root of n, we're going to want to manipulate that. So if you remember correctly, with division, we changed that to a subtraction problem. Log 20 minus log square root of n. But my n is still not by itself. It has this radical on it. So we're going to change this to log of n to the 1/2. And now I can change it again to 1/2 log n. So now, again, basically I'm expanding. I'm taking a problem, getting rid of the exponents, and trying to make it as simple as possible with logs. So I know it looks more complicated, but I promise we're getting somewhere with this. So that's my second example. Now we also want to be able to go backwards. Okay? Let's say I have a problem that has a lot of logs in it, like this. Log a equals log b plus, oops, I guess I should write that right. Plus 2 log c, okay? So what I need to do first is I need to be able to get to a point where I can combine these logs. As long as this 2 is here, I cannot do it. So I'm going to go log b plus, I'm going to change this to an exponent, log c squared. Now I can add them together. Remember, when you add, we multiply. So log b times c squared equals log a. Now I have two monomials with logs. Those logs can cancel out, and I'm left with a equals b c squared. One more example. log m equals 3 log a minus 2. Now, if you remember from yesterday, when we have just a number, we can rewrite that as a log, and we're going to need to rewrite that as a log to get rid of the logs. So this over here stays the same right now. Nothing happens to my, well, actually, let's do this step really quick. Okay. If I'm trying to get rid of the 3 there, we're going to move it over to in front of the, behind the a. So I have log a cubed. Now, 2 becomes log 10 squared. Now, since I have no numbers in front of my logs, I can simplify further to log a to the third over 10 squared. This equals log m. And notice again, I have 2 monomials, 2 logs. I can cancel those out, and I have m equals a to the third. And I'm going to simplify this just a little bit over 100. That's it. I will post your homework on Edmodo.